There is one more example on page 194 that I want to show you. So let's look at page 194. I'm not going to number that again. Let me just give you the function that we're going to use. Actually, let's go ahead and just draw the table and we'll put the function in there. So we're going to go long again on this one. And I'm going to use their example, I believe. 7 rows. And then some columns. So X will be here. Remember, your X's must be consecutive. You can't skip any values or this won't hold true. So we're going to start with 0 and go to 6. Actually, let's just go to 5 because that's all I numbered. It's fine. It'll work. Yes. All right, so our function this time, f of x equals 2 to the x power. I know it looks bizarre. It is bizarre, actually. So let's do some substitution here. So we have f of 0 equals 2 to the 0 power. Anything to the 0 power is 1. Then f of 1, we have 2 to the first power, which is 2. F of 2, we have 2 to the second power, which is 4. F of 3, we have 2 to the third power, which is 8. F of 4, we have 2 to the fourth power, which is 16. And then f of 5, we have 2 to the fifth power, which is 32. Okay, so we have our x's. And we have our f of x, which is synonymous with y. So let's start mapping out those consecutive differences. And we'll have to see where it becomes common with this very funky function. So the first consecutive difference will be 2 minus 1 is 1. Then 4 minus 2 is 2. Then 8 minus 4 is 4. 16 minus 8 is 8. 32 minus 16 is 16. Now, you may already notice the pattern. If not, let's do another one. That was the first one. So here's the second consecutive difference. Okay. So really all I need to see is this set of numbers. So I have 2 minus 1 is 1. 4 minus 2 is 2. 8 minus 4 is 4. And 16 minus 8 is 8. And then I ran out. So the second consecutive differences are not common either. Do you see the pattern? I'm going to take it one more to the third consecutive differences. And that's as far as this old gal's going to go. But you'll see the pattern, I know, when we finish, because I'll show it to you. So third consecutive difference. I have 2 minus 1 is 1. 4 minus 2 is 2. 8 minus 4 is 4. And this is the final column for me. So what's happening here? If you had to answer that question, what would you say? I would say nothing's happening. Because each time I do this, even starting back at f of x, these values are just repeating over and over. Now the list gets shorter each time, but here's the conclusion we can draw. There is no common consecutive difference. As long as we cared to do this, this process will repeat. Now let's think about it, why that would be. Because x, remember, that's what determines the degree. Whatever is in this seat is what determines how many columns you'll have to make. X can literally be anything. And because of that, we'll never get a common consecutive difference. Because there is no finite condition on x. It could be anything you want it to be. So you could do this all day long and you'll never get a consecutive common difference for this function. Wanted to go through that to let you know that not all functions have a common consecutive difference. Linear functions do. Let's look at one of those. There's a linear. There's a linear. Quadratics do. Cubic functions do. But some functions do not. And I wanted you to know that. One other thing, you can work these on your calculator using those same keystrokes. Anytime you have an exponent, this exponent key will help you. This is called the exponent key. Okay, I'm going to stop this video and we will come back with another example.